All right, welcome to the latest video, Systems of Equations. In this video, we're going to talk about some vocabulary, super important, like what's a consistent system, what's an inconsistent system, what's the solution to a system of equations. First of all, what's a system of equations? And last but not least, we're going to talk about how do we solve equations graphically and algebraically. Hope you enjoy. All right, let's look at these two equations, y equals 3x plus 2 and y equals 3x plus 4. Well, what do you notice about these equations right away? Well, the slopes are the same. If the slopes are the same, we have two possibilities here. If they have the same intercepts, well, they'd be the same point. If they have different intercepts, they would be parallel. So because we have intercepts of 4 and intercepts of 2, the lines are parallel. Let me show you a better version. All right, have a look at these graphs. The orange graph is 3x plus 4, and the green graph is 3x plus 2. So these lines are parallel. Now, are these consistent or inconsistent? Well, there's no solution, so you got it. Has to be inconsistent. So if you have an answer, no answer to a system of equation, you can write no point of intersection, or you can use a great vocab word, inconsistent. All right, let's try to solve these algebraically and see what happens when there's actually no solution. This is interesting to see, at least I think so. So look at this. We already have our equality, so we can say 3x plus 2 equals 3x plus 4. So let's think about this for a minute. If 3x, or 3 times some number, plus 2 has to equal 3x plus a number 4, and 3x and 3x are already equal, then that means that 2 has to equal 4. Well, we know 2 does not equal 4, so we know this is to be false, and therefore there's no solution. So often when we get nonsense in our work, it's the math telling us there's no solution. All right, let's look at two more equations. 3x minus 2y equals 4, and y equals minus 2x plus 5. Now, first of all, the first one's in no form, and the second one is in slope-intercept form, and neither of them are very easy to work with at the moment. So my recommendation would be, just to make it user-friendly, try to do something with them so they sort of look the same. So let's do this. Let's leave the same one as it is. And then let's bring the 2x plus y over equals 5. So at least now we know what we're dealing with. Let's look at our coefficients and let's do a check. Well, I have a 3 and a 2, and then I have a minus 2, and there's really a 1 there. So I think what I'd like to do is multiply the second equation by minus 2. Yes, I said minus 2. Because look at the magic that happens here. Minus 4x minus 2y equals minus 10. So when I've done that, I now have equality. I'm just going to rewrite the other equation here for a minute and have a look. All right, I found my two equal things. Yay. So let's isolate our two equal things. Now I just want to talk for a minute here about other methods of solving equations. You can do this by addition or subtraction. There's lots of ways to do this. I actually quite like this method. It deals with a lot of the sign issues that occur later on, and it gives you one method that works for everything. So if you happen to find another method that you love, go for it. If not, I think using the equality method is a great starting point. All right, now we're back to if a equals b and a equals c, then b equals c, so I can say 4x minus 10 equals minus 3x plus 4, and I can crisscross this one here. That gives me 3x, that's gone. Bring my minus 10 over here, becomes positive 10, that's nice to work with. So 7x equals 14, oh charming, x equals 2. What does every x need? Well, of course, it needs a y. We have lots of options now. We can put the value that we found for x into the first equation, the second equation, the rearranged second equation, the equation that's been multiplied by minus 2. Any of them will work. Let's go with the classic y equals minus 2x plus 5. So now we can put in our value for 2, and we have minus 4 plus 5, which of course is 1. So our point of intersection is 2, 1. All right, our intersection point is 2 and 1. Even I was fooled by this grid. Here's a scale here of 2, but look at this. This goes up in 1. So this does look wrong, but it is in fact scaled correctly at 2, 1. So there you have it. We have our point of intersection of our two lines, and we've solved it algebraically. And this is the graph of the two lines and their solution. So here's these two equations again, 3x minus 2y equals 4 and y equals minus 2x plus 5. I just wanted to spend a minute before we move on to another question here, looking at how you graph these. So again, let's look at this idea of finding our intercepts. So if I make x equal to 0, my y is equal to minus 2. If I make my y equal to 0, x is equal to 4/3. So when you're graphing 4/3, you just have to be approximate, 1 1/3, best you can. If you're using technology, of course, you're going to get a much better answer. Now, the second one, gotta love it, it's already in slope-intercept form. So we know for this equation, we would start at 5, and when we go down to 1 over and connect it. Or, from here, we already know that our y-intercept is 5, and we just need one more point. Well, why don't we put the value of 1 in? So if we do minus 2 times 1, that's minus 2. And what's minus 2 plus 5 is 3. So now the points 0, 5 and 1, 3 are on the graph. So there's a quick idea of how to graph those two lines. All right, let's look at the next two sets of equations. 0.5x plus 3y equals 6. Yes, that's 0.5. And x plus y equals 7. Well, let's think about this for a minute. Let me just rewrite this in fractions. 1/2 x plus 3y equals 6. I can already hear you yelling at the screen, no fractions. Well, if you know the magic of how to get rid of the fractions, we're just going to multiply everything through by 2, and the power of television, that turns into x, that turns into 6y, and that turns into 12. And then we still have x plus y equals 7. So now this is just one more step ahead of our previous method. All right, let's look and see. Is there anything equal? You bet, our x's are equal. So we can say x equals minus 6y plus 12, x equals minus y plus 7. We can also then use our a equals b, a equals c idea. So minus 6y plus 12 equals minus y plus 7. All right, let's keep going. I'm going to bring the minus 6y over, and it becomes positive 6y. The positive 7 becomes minus 7. 12 minus 7 is 5. And 6y minus y is 5y. Oh, this is working out well. Y equals 1. Well, what does every y need? You got it. It needs an x. So let's go back and have a look. Oh, x plus y equals 7. That's easy enough. X plus y equals 7. Well, if x is 1, you got it, x is 6. So that's the point of intersection for those two equations of 6, 1. Let's have a look at the graph. All right, there's our two lines graphed, and there's our point of intersection at 6, 1, just like we found algebraically. So all you have to do with fractions is just do that one more initial step, and you got it. Alright, let's look at one last question. This question is a little bit tricky because it already has fractions in the numerator. So what are we going to multiply everything by in the numerator? Well, let's multiply everything by, you got it, 6. 6 times 1/2 x plus 2/3 times 6y equals 6 times 6. Okay, let's do some simplifying here. 3x, 2 times 6 is 12, divided by 3 is 4y. Equals 36, and then we have the other equation, which is here. All right, well, what's our equal thing? Well, there we go. That's our equal thing. That makes it easy. So watch your signs here. 3x equals minus 4y plus 36, and 3x equals 2y plus 9. and we can do our equality. So minus 4y plus 36 equals 2y plus 9. Bring this over is 4y. Bring that back. So now I get, what is 36 minus 9? That's 27, and that's 6y. And then this is horrific. Y is equal to 27 divided by 6. All right. Well, nobody ever said math was pretty, but that's our y value. So, what does every y need? Well, every y needs an x. So let's go back to 3x minus 2y equals 9. 3x minus 2y equals 9. And we're going to substitute in our horrific value, which is y is 27 over 6. But I think I see the light at the end of the tunnel here. How many times does 2 go into 6? 3 times. How many times is 27 divided by 3? 9. Aha. 3x minus 9 equals 9. 3x equals 18. And x equals 6. So, the point of intersection is a nice 6 and 27 over 6. Sometimes that's just how the cookie crumbles. Let's have a look at the graph. All right, there you have it. 6 and 4.5, which is the same as 26 divided by 6. So, may not be pretty, but that's the answer. All right, as we wrap up, I just want to talk about how you graph these. So let's look at the first one. A lot of people are intimidated by the fraction, but if you just use the intercept approach, let's say I make x equal to 0, well, then 2/3 y equals 6. And we always say if it's on the bottom and it crosses the equal sign, it goes to the top. And if it's on the top and it crosses the equal sign, it goes to the bottom. So in this case, y is equal to 18 divided by 2, which is 9. So that's your y-intercept. Let's look at your x-intercept. Let's set y equal to 0. That leaves a half, x equals 6. Well, a half times what equals 6? Only one number, 12. So there's a quick way to find your intercepts. All right, let's do it for the second equation. Okay, y-intercept, set x equal to 0. Your y-intercept is going to be minus 9 over 2, or minus 4.5. If you want to find your x-intercept, set y equal to 0, so therefore 3x equals 9, x equals 3. So there you have it, another quick way to graph your even hard-looking equations just using the intercept model. I hope you try it.